Hey, hi and welcome back. I hope that you enjoyed the practical demonstration of microcontroller section. So in this video, I'm going to show you the practical demonstration of RGB LED section, and along with that, we will see some testing and troubleshooting technique associated with RGB LED section. Alright, so now let's start with this video. So now let me tell you what you're going to learn in this video. So the first point is a practical demonstration. So I'm going to show you the practical demonstration of RGB LED section, and for that we are actually going to program the code in the controller to test the RGB LED section, and this is basically the sub point, which is program flow. So when I will show you the practical demonstration, prior to that I will show you the flow of the code. So just to make the things simple, as this particular training is completely dedicated to the hardware, so I'm just going to discuss the flow of the code, okay, in the layman's language. I'm not going to discuss the code in detail, okay. So I will explain you the code in the layman's language, which means what exactly is written or how exactly the code is written, okay. Then the next point is program MCU to check RGB LED. So we are going to program the same code in the microcontroller, and we will check whether the RGB LED is working properly or not, okay. So all these things we are going to do in this particular point, which is practical demonstration. Then the next point is testing and troubleshooting. So I will discuss the testing and troubleshooting techniques associated with the RGB LED section. So there are actually not much testing and troubleshooting tricks to test the RGB LED. So whatever techniques are there, I will discuss with you, and you can use those techniques to, whenever you will deal with the RGB LED, okay. And ultimately the last point is mistakes. So I will discuss the mistakes that you should avoid when you deal with the RGB LED section, okay. And again, I'm going to discuss the mistakes that I have done in past related to RGB LED, okay. So this is how basically we are going to cover this video. Now let's start with this point, which is practical demonstration. And before I show you the practical demonstration, let me show you the program flow. So now let's discuss the flow of code that we are going to program in the microcontroller. So the first point is microcontroller start. So as soon as the power is provided to the system, the controller will start. And then the next point is any one LED out of RGB will switch on at a time in a sequence of RGB with a delay of 1 second. And this will execute in a loop for 4 times, okay. So what exactly that means? Initially, the red LED will get switched on, and it will remain switched on for the 1 second. And after that, the red LED will switch off, and then the green LED will get switched on. And again, this particular LED will remain switched on for 1 second. And after that, it will get switched off, and then blue LED will get switched on for 1 second, okay. So in this way, this RGB LED will get switched on, and this particular action or this particular sequence will execute for the 4 times, okay. So RGB, and after that the red LED will get switched on, then green, blue, and again in the same way it's going to execute for the 4 times, okay. So that's basically the second line. Then after that, all LED will get switched on for 2 seconds. So that's basically the third point. Then the next point is any one LED out of RGB will switch on at a time in a sequence of RGB with a delay of 500 milliseconds. So same thing is going to happen in this particular line. It's just that in this case, the delay between the two LED is actually 500 milliseconds, okay. In this case, it was 1 second. In this case, it's basically, 500 milliseconds. So RGB LED will get switch on and switch off even more faster, okay. Then the next point is all LEDs switch off for 2 seconds. So after this, all the LEDs will get switched off for 2 seconds. And then the next point is any one LED out of RGB. So again, the same line, in this case, delay is 200 milliseconds, okay. So in this line, the delay was 1 second. Here it was 500 milliseconds, and in this case, it's 200 milliseconds. So here the RGB LEDs are going to, the pattern is going to be even more faster, okay. So that's basically this point, and in the end, all LED switch off with a delay of 2 seconds. And then the last point is red LED intensity will go from 0 to maximum, and from maximum to 0, and this will execute in a loop for 4 times, okay. So initially the red LED will remain switched off, and slowly its intensity will increase to the maximum, and from maximum the intensity will drop to 0. Okay, so this is going to execute for the 4 times. Okay, and in the end the code execution will be stopped. Okay, so microcontroller will stop the execution. Okay, so that's how basically the code is, and this code we are going to program in the microcontroller. I hope that you got the flow of the code. Okay, now let's see the practical demonstration. Alright, so now let's program the code in the microcontroller and let's test this RGB LED section. Okay, so first of all, let me switch off the lights, otherwise the LED or this RGB LED will not be properly visible on the camera. So I will switch off the lights now. Alright, so now the lights are switched off. Now let's program the code in the microcontroller. So this is basically the code to test the RGB LED section. So you can explore this particular code. Okay, and after that, whenever you program the code in the microcontroller, you always have to first of all, select the board. So we are actually treating this hardware as a Arduino Uno. That's the reason we have to select the board as a Arduino Uno here. I have already discussed this particular point, and later the COM port is going to be COM11. Okay, so which is already selected. Now let's program this code in the microcontroller. So you can also check the status here. Okay, so whether the code is compiling, whether the code is uploading in the microcontroller, so that status you can check here. So the code is now programmed in the microcontroller, and you can see right now the LED is changing the color with a delay of 1 second. And now the LED will switch off for 2 seconds. So you can see, and now the LED is actually changing the color with a delay of 500 milliseconds. Then again LED switch off for 2 seconds, and now the delay is 200 milliseconds. And again the switch off for 2 seconds, and here the intensity of red LED, it's going from 0 to maximum, and from maximum to 0 for the 4 time. Okay. Alright, so this actually ensures that this RGB LED is working perfectly fine. Okay, and there is no issues related to this RGB LED. Now let me switch on the lights. So in our case, this RGB LED is working perfectly fine. Now let's discuss the testing and troubleshooting techniques associated with this RGB LED. Okay, so if the RGB LED is not working, then the first point that you have to consider is the polarity of RGB LED. So here actually you can see this is basically this is actually the notch of this RGB LED. I hope that it's visible on the camera. So this is basically the notch of this RGB LED, and whenever you solder the RGB LED, you have to make sure that the polarity of the RGB LED is proper. Okay, so if you soldered the RGB LED in wrong polarity, then it's obvious that the LED is not going to switch on. So whenever you solder the RGB LED, first of all you have to make sure that the polarity of the RGB LED is correct. So this is basically the notch of RGB LED, and this is going to be the pin number 1 of the RGB LED. So accordingly you have to solder this particular LED on the PCB in a correct manner. Okay, so I hope that this particular point is now clear. So after checking the polarity, now you are sure that the polarity is correct, but still if the RGB LED is not working, then you have to make sure that the soldering of the RGB LED is done properly. Okay, so it might happen that you may find some dry solder. So because of dry solder, there won't be proper contact of the pin of RGB LED with the pad on the PCB. So you have to do the touch up in that case, and later the RGB LED will work properly. Okay, but still even after that, if the RGB LED is not working, then you have to check the points on the the pins of the microcontroller which are actually connected to the RGB LED pins. Okay, and you have to check whether whether the controller is actually producing the signal for all the pins of the RGB LED or not. So if the signals are produced by the controller on the respective pin, it means that at least on the controller side there is everything is perfectly fine, and the problem is only with the RGB LED. So in that case, what you can do, you can simply replace this RGB LED, and you can put a new LED instead of this one. Okay, now again, when you will solder the new RGB LED on the PCB, at that time, before soldering the RGB LED on the PCB, you have to check that particular RGB LED. In case if there is a problem even with the new RGB LED, then unnecessary, it will be lot of efforts. Okay, so you have to make sure that before replacing the LED or before soldering the new LED on the PCB, you have to externally check whether the RGB LED is working properly or not. Okay, and once you are sure that the RGB LED is working, then you can solder the RGB LED on the PCB. Now I will show you how to test the RGB LED, okay, with the help of multimeter. So this is basically one of the most important thing that you have to do. So I will show you the procedure now, how to test the RGB LED with the help of multimeter. So we have this RGB LED with us. Now let's test this particular RGB LED. Okay. So in order to test this RGB LED, you have to put your multimeter in the continuity mode. Okay. So I have placed the multimeter in the continuity mode. So you can see. So I have placed the multimeter in the continuity mode, and using the two probes of the multimeter, you have to check, the first LED. First of all, I will check. So you can see the green LED is switched on. It means that this green LED is properly working inside the RGB LED. Then the next LED is red LED. So you can see the red LED is working perfectly fine. And after that, the last LED is blue LED. So again, it's working perfectly fine. So likewise, you can check the RGB LED whether it's working properly or not. And once you are sure that the RGB LED is working properly, and then you can actually solder the RGB LED on the PCB. Okay. So that's how you have to check the RGB LED. Alright, so now let's discuss the mistakes that you should avoid when you deal with the RGB LED. Okay. So, when we solder the RGB LED on the PCB, we have to solder the RGB LED properly, because the body of the RGB LED is actually made up of plastic. Okay. So if you are not soldering the RGB LED properly, then you may actually melt this RGB LED's body. Okay. So while soldering the RGB LED, you have to make sure that you have to solder properly. So that's basically the first point. Then the second point is, again, while soldering the RGB LED, you have to make sure that you are quickly soldering the RGB LED. Okay. So if you hold the pin of RGB LED at a, if you are trying to solder one of the pin of the RGB LED for a longer duration, then because of that, the glass which is there on top of this RGB LED, it may get cracked because of overheating. Okay. So that's the reason you have to make sure that you have to quickly solder the RGB LED. Otherwise, the glass will get cracked, and because of overheating, again, you may damage the RGB LED. And same thing is true in case of, when you are using hot air gun to solder the RGB LED, you have to make sure that you have set the airflow properly, and you have set the temperature of hot air gun to right temperature. Okay. So because of excess heat, you may damage the RGB LED, and you can also, crack the glass of the RGB LED. So these are basically 2-3 mistakes that you should always keep in your mind whenever you deal with the RGB LED section. Okay. So I hope that all the mistakes are now clear to you. So in this video, I gave you the practical demonstration. Then we discussed the testing and troubleshooting techniques associated with RGB LED section. And then I shared the mistakes that you should avoid when you deal with the RGB LED section. Okay. Alright, so that's what I wanted to tell in this video. Now I will see you in the next video, which is about testing switch section. Okay. So I will see you in the next video now.